All right. My presentation will probably run a bit early as well. And this is something that I've kind of given a couple of times now at several different venues, so apologies if you've seen this before, but I just wanted to talk today about some work we've been doing at Princeton to analyze the costs of DNS, DoT, and DoH for the modern web. What we mean by that is we're really trying to understand how these different protocols affect the end user experience. So not just measuring things like query response times, but also page load times, and then emulating different cellular conditions as well, and seeing how they perform. So, DNS privacy has become a significant concern recently, especially within the IETF. We know that on-path network observers can observe traditional DNS traffic in the clear. So this is what I'm going to refer to the rest of the talk as DoH 53. And so there have been two protocols that have been proposed to encrypt this traffic. There's DNS over TLS or DoT, and then DNS over HTTPS, which I'll be referring to as DoH. And so what we wanted to do, as I mentioned, is do an extensive performance study of these different protocols. So again, not only measuring query response times, but also page load times, and measuring how the protocols perform on emulated network conditions. And we performed these measurements from 5 different global vantage points, but for the sake of brevity, I'm just going to be focusing on one in this talk. But we have some ongoing work in which you'll be able to see the full results. So the kind of key takeaway that I want for you to take away from this talk is that despite higher response times for DoH, we're actually observing that the page load times can be faster than with DoH 53. This is actually with DoT and DoH, I should say, which we didn't expect at all going into this work, and we'll give a couple of reasons of why we think that might be the case. So just starting off, this is some DNS response times we observed from Cloudflare at Ohio. So the way we configured this is we use Cloudflare's 1.1.1.1 resolver. Just measuring DNS response times to it. So whenever we use DoT and DoH, we also reuse the TLS connections. As you can see here, we see that for about DoH outperforms about 25% of DoT queries. As you can see on the bottom, this is just for the first about 250 milliseconds on the x-axis, but then you can see on the shorter plot that this is going up to 1500 milliseconds. So although DoT is taking over in the beginning, DoH manages to outperform it. And then what we're seeing is that actually in this kind of tail of the initial response times, that DoH is actually catching up to DoH 53. So it's not strictly the case that if you use an encrypted transport that you're going to get slower DNS response times. And we see this with DoT as well, that it's also catching up. And I want to note that this is not only the case where we're catching up to a local resolver, which when I say default DoH 53, I'm referring to the local just DNS resolver getting us to us over DHCP. But this is also outperforming even Cloudflare's own DNS resolver for DoH 53, which we'll also go into that a bit more of why we think that might be the case. This is with Google as well. So same idea, we have a vantage point on Amazon EC2 in Ohio. We're comparing all the different protocols with Google's resolver, and then also comparing the performance to the local resolver given by Amazon. And we're seeing similar behavior that kind of in this tail response times that DoH is catching up to the different protocols. So again, it's not strictly the case that you're getting slower response times, but rather there's this kind of interesting trend where, very quickly actually within 250 milliseconds of response times that the protocols are all catching up to each other. And then lastly, this is from Quad 9. So interestingly, we found that DoH is actually outperforming DoT for almost all the queries. There seems to be this behavior we observed where it appears as if the DNS responses aren't being cached from Quad 9's DoT resolver. We reached out to them and tried to understand the performance that we got, showed them our source code, and we had some initial conversation but couldn't come to a conclusion. But then we're also observing, once again, as with Google and Cloudflare, that DoH is catching up to traditional DNS or DoH in the tailored response times. So the kind of key takeaway here is just in terms of query response times that DoH can actually catch up to and even outperform, we noticed in some cases, DoH. This is within, within Cloudflare, within Quad9, and within Google. And so to kind of dig into what I mean by that a little more is we found that in terms of response times, DoH actually has a higher mean overall, but a lower variance than unencrypted DNS, a much lower variance. And this is a result that we observed across different vantage points as well. But again, for this talk, I'm only going to be going to the results we observed from Ohio in EC2. And there's a couple of explanations we thought about. One is just wire format caching, where it might be the case that the entire wire format is getting cached and for HTTP, and that might enable faster response times. Not exactly clear how much they might improve response times. But we also thought that maybe in the case of a CDN like Cloudflare, they might be doing HTTP caching at the edge, very close to the user, which might also be improving response times for DoH in comparison to traditional DNS. So we also want, as I mentioned earlier, wanted to emulate different cellular conditions. So the reason why we did this is that we're starting to see that DoH and DoT are being offered on phones, whether it's Cloudflare's 1.1.1.1 app. We're also seeing that Android 9 supports DoT. And so we thought it would be important to measure how these different protocols perform on phones, given that there's becoming more adoption for encrypted DNS protocols. And we figured the performance might also be significantly different. But unfortunately, we weren't able to set up our measurements on a real mobile network. So we settled for emulating these cellular conditions. So we did 4G, kind of a lossy 4G, where it's the same 4G conditions, but with 1% more packet loss, and 3G. These were conditions that we were able to emulate based on numbers that we got from an open signal report. So this is comparing all the different protocols for Cloudflare to Ohio in terms of page load times. And the way you can read this is that this is taking the difference in page load times for, given two protocols. For example, on the left, you have Cloudflare DoT and Cloudflare DoH. You're taking the page load times, comparing them to each other, and subtracting the difference. And the kind of vertical line you see in the middle is the median. So basically, the way you can read this is that if you're looking at DoT, DoH, and DoH in terms of page load times, in the median case, they're all performing very similarly, right? There doesn't seem to be this observable difference between the protocols and page load times. And this is on just the default network conditions without any kind of emulation or traffic shaping at all. So for example, we see that DoT was actually only 1 millisecond slower in the median page load time than DoH. So really no observable difference there. And in the case of DoH, it was 19 milliseconds slower than DoH. So we're kind of seeing this ordering of where DoT is performing slightly slower than DoH, and then DoH is performing slightly slower than DoT. So now we go on to the emulated 4G network conditions. What we're seeing is that the performance is changing a little bit. So we still see the same performance with DoT, where on these emulated 4G network conditions that DoT is performing just slightly slower than DoH in the kind of median page load time. But when you look at DoH, it's gotten significantly slower, where DoH is 70 milliseconds slower in the median page load time than DoH. And now if you go into the lossy 4G, where we took the same 4G settings and add an additional 1% packet loss, we're seeing even more interesting behavior, right? Where now DoT has gotten 62 milliseconds faster than traditional DNS in page load times, which we didn't expect to see at all. And with DoH, now DoH has actually also gotten faster than DoH in terms of page load times, now 20 milliseconds. So there's this kind of interesting behavior where as you've gotten to worsening network conditions that DoT and DoH are able to actually outperform traditional DNS. But everything kind of collapses when you go to 3G network conditions. So you're seeing here that DoT and DoH are performing much slower than unencrypted traditional DNS. So in this case, DoT is 197 milliseconds slower than DoH53. And similarly, you're seeing with DoH that it's 260 milliseconds slower. So the kind of key takeaway here, just to reiterate, is that we're seeing that it's not necessarily the case that just because you're using DoT or DoH that you're going to get worsening performance, that actually under certain network conditions, you might observe the case where it's actually faster. And this was a really unexpected finding. We weren't sure how we got to this, but the kind of most likely explanation we've got to is that it might be retransmission times with TCP compared to UDP. So the TCP packets could be retransmitted within 2 round trip times, whereas for DoH53, the timeout is set to 5 seconds by default in Linux with resolve conf. And so what we're thinking is that as you get into lossier network conditions, particularly as you observed going from 4G to lossy 4G, it might be the case that as packets are getting retransmitted, that you could actually retransmit faster over TCP, which we think might help the performance of DoT and DoH in page load times, despite the fact that you might have higher DNS response times. So just to summarize, we did a performance study of DoH53 DoT and DoH where we're comparing query response times, page load times, and emulate network conditions. In future work, we're wanting to do performance analysis over a diverse set of networks where it might be residential ISPs across the United States rather than just Amazon EC2 instances. And we also want to do measurements in networks that are kind of further away from CDNs. We're working with a university in South Africa and some colleagues there to run some measurements across Africa and some instances they have set up there. So I know this was a short talk and last talk of the day, so I appreciate you taking the time to listen, and I'll take any questions.
Yeah, I'm Carl Auerbach, and I was wondering if you'd observed any sort of issues with slow start and congestive backoff on the underlying TCP. That's one of my questions. I'm just going to give you the whole list of them now. You can address
Sure.
it. The other one was, have you tried anything out with Quick to see if there's any other variations to using that as the underlying transport? And the third part have you dealt with this sort of thing over any buffer bloat situations? So
to your second question about whether we've tried this with Quick, we haven't yet. This was just strictly over using, for example, for DoH, using just HTTP2, which we had configured just because that was the recommended setting in the RFC 8484. As far as any issues with buffer bloat, that wasn't something that we had measured or observed, but that would be an interesting thing to look into. Yeah, I mean, that's just something that we didn't look into or measure.
Andrew Dahl, 8 Continents. Are all your DNS over 53 queries UDP, or were there any TCP queries in there?
They were just over UDP for this study, but again, as we gotten comments on this presentation before about wanting to also measure over TCP because we just didn't expect at all to get this kind of a result. So in ongoing measurements that we're doing now, we're also going to be measuring over TCP to really tease out this performance.
Okay, thanks.
All right, thank you.